All right, take your homework out if you would, please. Books open to page 60. Page 60. And on numbers 13 through 20, we were reducing each function to the cofunction of a positive acute angle. And we said that in order to change to the cofunction, you basically do what we were doing before with the same function. And then once you've got same function, you convert it to the cofunction. So on number 13, we have the secant of negative 220 degrees. Well, what's the first thing I'm going to have to do here, Chris?
Add 360?
Yeah, we've got to get it in the range of 0 to 360. So we'll add 360 to change it into the secant of 140. Once we've got it between 0 and 360, we can easily identify class which quadrant it's in class it's in quadrant 2. And also in identifying quadrant 2, we know whether we're looking at 180 or 360. In this case, quadrant 2 class, we're looking at 180 to get a reference angle, Quentin, of 40 degrees. And then also, we need to also think through what SIGN will this function be based on ASTC. Quadrant 2 class, secant is negative. So initially, we're going to change this whole thing, Ethan, into negative secant of 40 degrees. Okay, that's the initial step. Now we need to convert it into the cofunction. And so to convert it into the cofunction, I said, what are we going to do with this sign right here, class?
Keep it.
Keep it. No matter what it is, keep it. Then secant turns into, not its reciprocal, not cosine. Secant changes to its cofunction, cosecant, and the angle changes to the complement, 90 minus, which gives us 50 degrees. And there's my final answer. How many had negative cosecant 50? All right, so Chris, you got as far as negative secant 40. We just forgot to finish the whole process. All right, so looking at the next one, we have the tangent of 5 pi over 3. And again, when it comes to radians, think what would pi be with this denominator class? 3/3. What about 2 pi? 6/3. Where is 5 pi over 3 in relation to 3/3 and 6/3? Fourth quadrant. Really close, right? And because it's fourth quadrant, we're measuring from the 6/3. What's the reference angle, class? Pi over 3. And so, ASTC now, we're going to change this whole thing, Chris, into...
Cotangent.
Not yet.
Oh, tangent. That's negative.
Negative.
Tangent of pi over 3.
Pi over 3. Once we've got the initial step, same function, now we convert it to the cofunction. But, what do I do with the SIGN class? Keep it. But tangent, Chris, changes to?
Cotangent.
And then the angle has to change to the,
Reciprocal.
not the reciprocal,
The
class
function.
complement, the complementary angle. In radians, though, it's not 90 minus, class, it's pi over 2 minus, because pi over 2 is 90. So we're going to take pi over 2 minus pi over 3. And let's get a common denominator, Chris. 6. And so multiply top and bottom by 3 to get 3 pi, multiply top and bottom by 2 to get 2 pi, and we get pi over 6. And there's my answer. How many negative cotangent pi over 6? For the second one. All right, on the next one, we have the cosine of negative 110 degrees. Quentin, first thing we got to do to get?
Cosine 250.
Once we've got it between 0 and 360, class, we can identify it's in quadrant 3. Good bit into quadrant 3, by the way, because you're measuring from the 180. What's that reference angle, class? 70. ASTC, how am I going to rewrite this, Ethan?
Negative cosine 70 degrees.
There we go. But we've got to change it to the cofunction. Quentin, how do I change it to the cofunction?
Keep sine 20 degrees.
There we go. Negative sine of 20 degrees. Keep the SIGN, change cosine into sine, and then subtract from 90 to get the angle. How many had negative sine 20 degrees?
I'm pretty sure all my answers are going to be wrong.
All right, but are you figuring out what you should have done?
I know what I should have done.
All right, that's the most important thing. How about this next one? The sine of 16 pi over 5. And again, anytime it's radians, look at the denominator, ask yourself, what would pi be? 5 pi over 5, and then 2 pi. Thoughts on 16 pi over 5?
You have the minus 2 pi.
Way too big, right? It's way past 2 pi. So subtract away the 2 pi, the 10 pi over 5 that you already thought through to get what, Chris?
6 pi over 5.
Sine of 6 pi over 5. Okay, now back to what we were thinking a moment ago. 5 pi over 5, 10 pi over 5. Where's 6 pi over 5, class?
Right into the third quadrant.
Just barely into that third quadrant, where the reference angle is going to be with respect to 5 pi over 5, so it's going to be
Negative 7 1 pi over 5.
1 pi over 5. Finally, ASTC, quadrant 3, sine is
Negative.
negative sine pi over 5. But we've got to change it to the cofunction, Ethan. So we're going to do what with the SIGN?
Keep it.
But the sine turns into,
Cosine.
and the angle we have to subtract from
5
pi over 2 minus pi over 5, common denominator, 10 multiplied top and bottom by,
5.
and here top and bottom by 2. So it's 5 pi minus 2 pi gives 3 pi over 10, and there is our function rewritten in terms of the cofunction. Questions 13 through 16, now that we've seen them all. Let's take a look at, you let Jamie in please, number 17. And number 17, we've got the sine of negative 505 degrees. Jamie, thoughts on negative 505 degrees?
You need to add 360 to it.
Let's add 360, and when we do, we'll get,
Which problem is this?
number 17. We started with sine of negative 505. We need to add 360 to get
145?
negative 140,
45?
yes, negative 145. Thoughts on the negative 145?
You need to add 360 to it.
Add another 360. And so now I've got the sine of,
I have 35, I'm not sure if that's right.
how about 115?
Okay.
115 degrees. And once I've got the sine of 115, now I've got something between 0 and 360. So now, Jamie, I can say, oh, I know this is in quadrant 2. And in quadrant 2, I'm measuring from the 180. How far from 180 is 115?
65?
65 degrees. And then finally, we'll think through ASTC. Quadrant 2 sine is,
Positive?
so we'll get the positive sine of 65 degrees. But then I've got to change it to the cofunction. Jamie, what do I do with the SIGN?
Keep it.
What do I do with the sine?
You change it to cosecant?
Ooh, not reciprocal, cofunction, cosine. And what do I do with the angle?
You minus it from 90?
Good, 90 minus to find the complementary angle, which is
25.
25 degrees. How many have the positive cosine of 25 degrees? Okay, only Ethan. Question, Quentin?
215 degrees.
It's 215 degrees? Thank you, sir. Well, if it had been 115, we would have done a great job just now, Jamie, but I lied. It's 215 degrees. So let's try the sine of 215 degrees. And so Ethan was wrong as well. You're right. Yeah, because we don't borrow when we subtract. We're not borrowing from the 3 to do 5 minus 4. 215 degrees. So it's not in quadrant 2, is it, Jamie? It's in quadrant
3.
3. And it's in quadrant 3. And so we're still measuring from 180, but now what's the reference angle, Jamie?
35.
35 degrees. And quadrant 3 sine is?
Negative.
Negative. So we're going to change this initially into?
A negative. Sine of 45 degrees.
And now we're going to change this into the cofunction. We're going to do what with the SIGN?
Keep it.
We're going to do what to the sine?
Change it to cosine.
And then 35 degrees becomes
55 degrees.
55 degrees when we find the complement. How about this one? How many have positive cosine
I
of
don't know what I
55
was
degrees?
thinking, but I got that. I was thinking another one, I think.
Okay. I just think he likes to raise his hand. All right, questions on what we
I'm
should
really
have done
sorry.
on the first one. I was just seeing if anyone was paying attention. I'm glad Quentin was. Good job, Quentin.
So
No, Quentin just didn't get the right
negative
angle on the
changes to
board.
positive? Or
Yeah.
Oh, wait, yeah. What are we supposed to do with the negative?
keep it?
Keep it, yeah. I think you even said keep it. I don't know why I wrote a positive. I was just seeing if you were paying attention. It's been a rough start to the class.
I feel like I have to say something now. That degree sign about the 55 isn't big enough.
You're right, it is awfully small. I was thinking if anyone was paying attention. Good job, Chris. Let's see, my turn to do something right. Let's go on to the next problem. Number 18. All right, the cotangent of 33 pi. It would really help if I had answers in here. Cotangent of 33 pi over 10. As is, I'm just at the mercy of whether or not anyone catches stuff. All right, cotangent of 33 pi over 10. And let's go to Ethan. Ethan, who likes to raise his hand for stuff.
Yeah.
Ethan, anytime we have radians, we're looking at denominator, we're thinking pi is denominator 10. Pi would be
10 pi over 10.
there we go, 10 pi over 10, and 2 pi would be
20 pi over
20 pi over 10. All right, and but I got 33 pi over 10. Thoughts?
minus 10 pi over or 25 over 10.
Yeah, it's too big. So we're going to subtract away 20 pi over 10, and we're going to change it to say the cotangent of
13 pi over 10.
13 pi over 10. Okay, now, thinking about the 13 pi over 10. We got 10 pi over 10, we got 20 pi over 10. Where's 13 pi over 10?
It is in quadrant.
Quadrant 3. It's bigger than 10 tenths, but it's way closer to 10 tenths than 20 tenths. Quadrant 3. The reference angle from 10 tenths would be
3 pi over 10.
3 pi over 10, and ASTC, quadrant 3 cotangent is?
It is positive.
So I'm initially going to get
Cotangent positive.
positive.
Cotangent 3 pi over 10.
There we go. But I'm going to change it to the cofunction. What are we going to do with the SIGN?
Positive.
Cotangent.
Tangent.
And then the angle I've got to subtract from
Positive.
pi over 2 minus 3 pi over 10, common denominator 10. So multiply top and bottom by
5.
5 to get 5 pi over 10, which gives me,
2 pi over 10.
or in other words,
Positive tangent of 2 pi 10. Or pi 10.
reduce
5.
pi over 5. There we go. Positive tangent pi over 5. You'll have 2 pi over 10 just minus a point. How many have positive tangent pi over 5? Questions on this one?
I actually got this one.
Okay, all right.
Let me see your paper.
You can't.
Questions on this? No, I trust him. He's a very trustworthy person.
That's cap.
Actually, it doesn't affect me one
More
way or the other.
trustworthy
It
than
doesn't
you are.
really. All right, questions
Very
on this.
trustworthy.
All right, enough of the argument. We don't need to do that on camera. People think you're immature or something. We wouldn't want them to get the wrong idea about the senior class. Cosine of 6 pi over 7. We're moving on quickly. Cosine 6 pi over 7. Let's go to Chris. Chris, anytime we see radians, we look at that denominator and we say, pi would be
7 pi over pi.
over 7, and 2 pi would be,
14 pi over 7.
where's 6 pi over 7?
Same quadrant.
Quadrant 2. Reference angle from 7 pi over 7.
1 pi over 7.
ASTC.
Negative. Cosine of pi over 7.
Now we're ready to change the cofunction.
Sine. Oh, negative sine. Positive over 7.
And then pi over 2 minus pi over 7. Because we have to find the complement. Keep the SIGN, change to the cofunction, and then find the complement of the angle. We need a common denominator of
5 pi over 7. Oh, sorry. I already said that.
14.
Yeah.
Multiply by 7, multiply by 2. We do get 5 pi over 14.
14, yeah.
So there's my answer, negative sine of 5 pi over 14. How many have that answer? Number 19. All right, Chris over there pulling an Ethan. All right, number 20, we have the cosecant of 295 degrees. Quentin.
Quadrant 4. Reference angle is 65.
Good. 65 degrees from the 360. ASTC.
Negative cosine. Or cosecant 65.
And now we'll change it to the cofunction.
Keep the sign. Secant 25.
And there we go, negative secant 25 degrees. How many had that for number 20? All right, questions on changing, first of all, to the same function. Questions on converting to the cofunction.
Oh, I would have gotten all of them right because I had the right reference angle to begin with for every single one of them. So.
All right.
Just
Just got to remember the complementary angle and we'd be good. All right. Any questions? Jamie, any questions? No, you out yesterday, stuck watching it on video. All right. Next section, your notes. Next section, your notes. Exact values of all special angles. Exact values of all special angles. And I say all special angles because up till now, we've treated special angles like there's the big 5. 0, 30, 45, 60, and 90. But there are more special angles than just those. Because every one of those angles over here on the bulletin board is also a special angle. Because every one of them has a reference angle that is either 60 degrees, 45 degrees, 30 degrees, 0 degrees, 30, 45, 60, 90, or 90, depending on which way you want to go. 30, 45, 60. All of these angles are special angles because their reference angles are special angles. And now I just wondered, did any of that actually show up on the screen? Yes, I did a good job. And I managed to cut Ethan's head out. Out of the camera. So let's go and flip it back over
That's
here
for after
again.
school. What would you say that?
All right.
Huh?
Let's come back over here. And if you're watching on YouTube and you just got very dizzy from watching all of that back and forth, if you're watching on YouTube, in the description of the video, you'll find a handout or a link to a handout. I'm going to be passing this handout out to my students, and it's a great, big, frightening chart that we are going to begin filling out.
Uh-oh.
Okay, so you can set your books aside. You won't need those for now.
You need them for the rest of the lesson.
We won't need your books the rest of the hour, no. All right, so let's go and take out the big frightening chart here, and let's work our way through. Now, I want you to notice, I'm going to kind of put this on the board here. You've got theta is the actual angle, right? And then theta rad, we're going to put the angle in radians for ourselves as well. And you notice 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. If you would, just draw a line under the 90 and label off to the side quadrant 1. Now, technically, 0 and 90 are quadrantals, but for our purposes, we're going to consider them parts of quadrant 1. We already know what these are in radians, class. 0 degrees is how many radians? 0. I'm going to fill that in. 30 degrees.
Pi over 2.
Uh-oh.
Pi over 6.
Pi over 6. 45 degrees.
Pi over
4. 60 degrees.
4. Pi over 3.
And 90 degrees.
Pi over 2.
Pi over 2. Okay, these are ones we memorized earlier. Then we get to rho. Well, rho is the reference angle, right? Well, because you're in the first quadrant, the reference angle is the angle. So the reference angle of 0 degrees, class, 0 degrees. 30 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Okay, that's easy, right? The reference angle just is whatever it is. And then, of course, the reference angle in radians, rho sub rad, is also the same thing. So the 0, the pi over 6, the pi over 4, the pi over 3, and the pi over 2. Pi over 5 just isn't special. All right, that's why we skip him. I know. And then, of course, we see the sine, cosine, tangent, cotangent, secant, and cosecant of theta. Well, for these, we just need to use our special triangles. So, for starters, let's think of the 0, 90, 90 triangle. Okay, so here's my 0 degree angle, my 90 degree angle, and the true 90. These sides are the same. We'll call them 1. This side we'll call 0 because it would be approaching 0. And for the sine, opposite over hypotenuse of 0 degrees, class. 0 over 1, which is 0. For the cosine, adjacent over hypotenuse. 1 over 1, which is 1. Tangent, opposite over adjacent. 0 over 1, which is 0. Cotangent is going to be the reciprocal of the tangent. What do you get if you flip a 0 over 1? 1 over 0, which is undefined. Secant's the reciprocal of cosine. What do you get if you flip a 1 over 1? 1. Cosecant's the reciprocal of sine. What do you get if you flip a 0? Undefined. Let's go to 30 degrees. For this, we look at our 30, 60, 90 triangle, and make sure we focus on the 30 degree angle up here. Of course, opposite 1, hypotenuse 2, adjacent, square root of 3. What's the sine of 30 degrees, class?
1 over 2.
1 over 2. What's the cosine of 30 degrees? Square root of 3 over 2. What's the tangent of 30 degrees? 1 over square root of 3, which becomes square root of 3 over 3. But if you flip it, what does it become?
Square root of 3 over 1.
Square root of 3 over 1, or just square root of 3, right? Because this was 1 over square root of 3, and that's easier to flip, isn't it? Secant, remember, is the reciprocal of the cosine.
2 over square root of 1.
2 over square root of 3, which becomes 2 square root of 3 over 3. And cosecant is the reciprocal of the sine. 2. Okay, this is all stuff we've done before. Nothing new whatsoever here in the first quadrant. This is just great review for us. 45 degrees. Doesn't really matter which of them you look at. The legs are the same anyway. There's the square root of 2. What's the sine of 45 degrees?
1 square root of 2.
1 over square root of 2, which becomes square root of 2 over 2. Cosine of 45. You can draw it on your own paper if you want it. I'll move the lecture down the way. 1 over square root of 2 again, or? Square root of 2 over 2. Tangent, what over what? Opposite over adjacent, so 1 over 1, which is 1. Cotangent, you're going to flip the 1. Secant, you're going to flip the 1 over square root of 2. Square root of 2 over 1, or square root of 2. Cosecant, you're going to flip this one. Square root of 2 again. 60 degrees. Focused here now. Opposite over hypotenuse.
Square root of 2.
Square root of 3 over 2. Cosine, adjacent over hypotenuse. 1 over 2. Tangent, opposite over adjacent. Square root of 3 over 1. Cotangent, flip the square root of 3. 1 over square root of 3, which becomes square root of 3 over 3. Secant, flip the cosine. 2. Cosecant, flip the sine.
2 times square root of 3.
Now let me come to 90. To focus up here. Sine, opposite over hypotenuse. 1 over 1, which is 1. Cosine, adjacent over hypotenuse. 0 over 1, which is 0. Tangent of 90, opposite over adjacent. 1 over 0, which is undefined. Tangent, we're going to flip an undefined. What do you get if you flip an undefined? 0. What do you get if you flip a 0? Undefined. What do you get if you flip a 1? 1. There we go. Questions on the first quadrant. Now we come to the second quadrant, where you see these angles listed: 120 degrees, 135 degrees, 150 degrees, and 180 degrees. Draw a line under 180, and I want you to write quadrant 2 off to the side. Technically 180 is quadrantal. It's not in a quadrant at all, but for our purposes, we'll consider 180 to be in quadrant 2. Now, for the angle in radians, I'm going to come back to that later. Let's instead go straight to the reference angle. In quadrant 2, we're measuring from what? 180. How far from 180 is 120? 60. How far from 180 is 135? 45. How far from 180 is 150? 30. And how far from 180 is 180? 0. So the reference angles are 60, 45, 30, and 0. Does that make sense? Now, what would these reference angles be in radians? Well, 60 is pi over 3. 45, 30, and 0, 0. Now think about this for a minute. We already know 180 is always equal to what in radians?
2 pi.
Pi. Pi is 180, right? But for the other three, they're going to be weird fractions, aren't they? Watch. The reference angle's pi over 3, but it's in the second quadrant, which means it's approaching 3/3, but it's not there yet, class. It's 2/3. 2 pi over 3. This has a reference angle of pi over 4, but it's in the second quadrant, which means it's approaching 4/4, but it's not there yet, class. It's 3 pi over 4, 3/4 of a pi. So what would the angle in radians be for 150? 5 pi over 6. It's approaching 6/6, but it's not there yet. It's at 5/6. Do you see how to easily figure the angle in radians without really doing any math? You've done the reference angle. You have those memorized in radians. Let the patterns talk you through these. Now, since 120 has a reference angle of 60, whatever we wrote down in the 60 row, we're going to write down in the 120 row. Does that make sense? They're going to be the exact same. So we're going to look at the 60 row. I want to put it down here. Square root of 3 over 2. Wait, but in quadrant 2, sine is
Negative. Quadrant 2 sine is
positive. Okay, so we're good. Cosine, we're going to write down 1/2. But wait, quadrant 2 cosine's
negative.
So we're going to put negative 1/2. Tangent, we have square root of 3, but quadrant 2, negative square root of 3. For cotangent, quadrant 2, negative, so negative square root of 3 over 3. Secant quadrant 2, negative, so negative 2. Cosecant quadrant 2, positive, so we're just going to keep the 2 square root of 3 over 3. Does that make sense? It's going to be the exact same as the 60, but cosine through secant all will come out negative. So what should we write down for the 135 row going across, Ethan?
For the, whatever, what's on the 45.
All right, so tell me what to write as you're writing it.
Okay, so square root 2 over 2. Positive square root 2 over 2.
Right, positive square root 2 over 2 for the first one.
Negative square root 2 over 3.
Good.
Negative 1. Negative 1. Negative square root 2. And positive square root 2.
There we go. See how easy this is? Except I'm running out of room because I think I'm going downhill slightly. Then we have the 150 row. What do you think we'll write down for the 150 row, Jamie?
We'll write down 1/2.
Right, whatever's in the 30 row. So 1/2.
Then negative square root 3 over 2. Then negative square root 3 over 3. Negative square root of 3. Negative 2 times square root 3 over 3. And then 2.
And then for the 180, we're just going to copy down the 0 row, right? But again, account for the fact that we're in quadrant 2. So what do we write down here, Quentin?
0, -1, -0.
Yeah, you can't really write -0, so we'll just leave, that's a 0, it just looks horrible. Let's try that again, okay?
Undefined.
Good, undefined can't be positive or negative either, so we'll just leave undefined.
-1, undefined.
Do we see how easy it is to complete the chart here? All right, let's go to the third quadrant. Let's go to the third quadrant, and I didn't mean to erase that. I'm going to have to erase the rest of this, though. You don't have to erase on your paper
I
anything.
think I remember coming in last year when you were teaching this.
Possibly.
Because I remember having like deja vu right now.
All right, so for the next quadrant, we have 210, 225, 240, 270. Draw a line under 270 and write quadrant 3 next to it. Again, technically 270 is quadrantal. It's technically not in a quadrant at all. But we're going to pretend it's in quadrant 3. Okay, it won't actually matter for the math's sake, as we'll show later. All right, now again, I'm going to skip the theta rad for now. I'm going to go straight to the row. Remember in quadrant 3 class, we're measuring our reference angle from, no,
180.
always the horizontal, measuring from 180. So what's the reference angle of 210? 30. What's the reference angle of 225?
45.
Reference angle 240?
60.
And reference angle 270.
And there's a pattern with this.
There sure is. And there's always patterns in math. It's beautiful. That's why I love math. Because once you see patterns, you save yourself work. I love saving work because I am lazy. That's why mathematicians love math.
We're all brainwashed.
Patterns make me lazy. All right, row rad. What is 30 in radians?
0.
Pi over 6. What's 45? 60? And 90. All right, now think about this. In quadrant 3, you are past 180, right? You're past pi. You're past 6/6. So class, you must be at 7/6. You're past 4/4. Class, you are at 5/4. 5 pi over 4. You're past 3/3. 4 pi over 3. You're past 2 halves. 3 halves. For sake of time, we're not going to fill in the rest of the chart, but you know what you would do, right? You find a row with 30s in it. You basically copy the row with 30 and for all the sine through cosecant, but in quadrant 3, you'd make sure which two stay positive? Tangent and cotangent are all going to be positives. Everything else gets copied with negatives. Here in just a moment. We're not going to do that now. Let's go to fourth quadrant. We have 300 degrees, 315 degrees, 330 degrees, and 360 degrees. I want you to write quadrant 4 next to all of this.
I don't have a 360.
You don't have a 360, never mind, because 360 is back to 0. That's right. 0 to 360, not including 360. So just these 3 in quadrant 4. Again, in quadrant 4, you're measuring reference angles from the 360. So what's the reference angle for 300? 60. For 315?
45.
And for 330?
30.
In radians, what is 60? In radians, what's 45?
4.
And 30 is?
6.
but you're almost to 2 pi. You're almost to 6/3, class. 5 pi over 3. You're almost to 8/4. You're almost to 12/6.
11 pi.
And of course, we would fill in the rows from here, except in the fourth quadrant, which functions remain positive?
Cosine,
secant.
Cosine and secant will remain positive. Everything else ends up being negative. We'll fill that in later. Set that aside. Just have at your spiral notebooks. So let's practice now actually finding, instead of just filling in a chart, though we'll finish that later, but instead of just filling in a chart, what if we just had to pick one at random and find the exact values? So next section, it's exact values of special angles outside quadrant 1. Exact values of special angles outside quadrant 1. Exact values of non-Q1 special angles. 'Cause I think that saves a little bit of time.
Sounds like a scary movie for like mathematicians.
All right, first of all, make sure your angle's between 0 and 360, or 0 and 2 pi. All right, make sure the angle's between 0 and 360.
This is step number 1.
This is step number 1. Step number 2, determine the quadrant. Step number 2, determine the quadrant. Step number 3, find the reference angle. Step number 4, determine the ratio based on row. Determine the ratio based on row. And step 5, ASTC. And there's my abbreviations, because I'm too lazy to write everything I just said.
I'm just gonna write all students take calculus.
There we go.
Lazy, no. You literally brainwashed us into being lazy.
It's true. All right, find the fastest, easiest way to do everything.
Except we do that in every class now.
Well, as long as you're finding the fastest, easiest way to accomplish everything, as long as stuff's still being accomplished, do it the laziest way possible. All right, like typing first drafts. All right, cotangent at 150
For
degrees.
real.
For real, right?
For real.
Cotangent at 150. First thing I need to do is figure out what quadrant, class.
Quadrant 2.
Quadrant 2, reference angle.
90. Oh, 60. 30.
30, you're basing it off of 180, okay? Now, what is the cotangent of 30? Well, looking over at the triangle, adjacent over opposite for 30. Square root of 3 over 1. But, ASTC. Quadrant 2 cotangent is negative square root of 3. I made sure it was between 0 and 360. Quadrant 2, reference angle 30. What's the ratio based on the reference angle? Not 150, but you're looking at 30. So using your special triangles, and then ASTC at the end to determine positive or negative. Write this one down. Secant of 240 degrees. Secant of 240 degrees. Quadrant?
Quadrant
3. Reference angle from 180,
3.
60. All right, what's the secant of 60? Hypotenuse over adjacent.
120.
2 over
Oh, sorry.
1.
Hypotenuse over adjacent, 2 over 1. So 2. But ASTC, quadrant 3, secant is negative 2 is our answer. We're doing what we did way back at the beginning of the year with our special angles. Sine, cosine, tangent, secant, cosecant, cotangent, right? We're doing all that still, but we have to figure a reference angle first. And we have to apply ASTC. But otherwise, we're doing what we've done before. So if we see cosine 120, well, class, that's in quadrant 2. So really, it says 120, class, but I'm thinking reference angle. So I'm really just thinking, what's the cosine of 60? We've been doing this all year. What is the cosine of 60? Adjacent over hypotenuse. 1/2. But there's one more step, ASTC, quadrant 2 cosines, so negative 1/2. Write this one down, the tangent of 315 degrees. Quadrant, reference angle,
45.
45. What is the tangent of 45?
One over 1.
1 over 1, or just 1. And quadrant 4 tangents, negative 1. See how quick and easy this can be? Just quickly thinking, making sure it's written correctly, right? But you'll catch it if it's not. You'll be like, whoa, something's not right, okay? You'll make sure it's between 0 and 360, coterminal angle rule if you need it, then quadrant, reference angle, ratio, don't forget ASTC at the end. How about the sine of 270? What quadrant?
Quadrantal.
It's technically quadrantal. I said we're going to treat it like it's in quadrant
Three.
3. But let's suppose you wanted to argue quadrant 4. Doesn't matter, because if you're basing it off of 180, how far is it? 90. But if you're basing it off 360, how far is it?
90.
Either quadrant you look, reference angle is 90, right? And what is the sine of 90?
0 over 1 over 1.
Yeah, 1 over here. I was over hypotenuse, 1 over 1. So it's 1. Now, ASTC, if you say it's quadrant 3 class,
Still negative.
it's negative. If you say it's quadrant 4, it's negative. And that's the way all of these functions will work out. With a quadrantal, it doesn't matter which of the 2 quadrants you put it in, the work will always come out the same either way. So that's why it's easier to just say, I'm just going to say it's quadrant 3 and roll with it, right? That'll just make your life easier than thinking of 2 things. Well, if I go this way, it's this way. Just pick one, right? So we'll just say 270 is quadrant 3, but it would work the same either way. All right, this one now, the secant of 330 degrees. Secant of 330.
Fourth quadrant.
Quadrant 4. Good. Reference angle.
30.
30. What's the secant of 30?
Secant of 30 is 2 over 1.
Ooh. 30, hypotenuse over adjacent.
Square root of 2.
Square root of 3 over
2 over
2 over square root of 3, which is 2 times the square root of 3 over 3, right?
That's right.
ASTC, quadrant 4, secant is
negative. Positive.
positive. And there's my answer. This one, cosecant, 180 degrees.
That's
Quadrant.
Either 2 or 3.
We'll just say,
We'll say 2.
but you know, I'm going to show both again just to reassure you this really works, okay? So let's say quadrant 2 or quadrant 3, either one. Now, if you measure from quadrant 2, we measure how far from 180. If it's quadrant 3, we measure how far from 180. How far from 180 is 180?
0.
0. Either way you go, right? So the reference angle is 0. Cosecant, hypotenuse over opposite, of 0.
Undefined.
Undefined. And if you're in quadrant 2, that's positive. If you're in quadrant 3, that's negative. But undefined isn't positive or negative. It's just undefined, so it doesn't matter.
So we love those.
Yeah. Questions on that? Let's go radians now. The sine of 7 pi over 6. Class, which quadrant?
Third quadrant.
Third quadrant, because it's a little bigger than the 6/6, which would be a single pi. What's the reference angle in quadrant 3?
Pi over 6.
Pi over 6. So quadrant 3, reference angle pi over 6, which my brain is going to say is 30 degrees. So what's the sine of 30 degrees?
Square root of 3 over
1/2. Opposite over hypotenuse. Looking at the 30, which is the top angle over
Oh,
there,
that's
Chris.
stupid.
All right, but quadrant 3 sine is
Negative.
negative. By the way, I'm not going to think pi over 6. I'm going to think 30. Okay. So tangent of 3 pi over 4. What quadrant?
2.
2. Reference angle. As soon as you see a denominator 4 class, you know the reference angle.
45.
45. Tangent of 45.
1.
1. And in quadrant 2, tangent is
Negative.
negative. We cruising?
Cruising too.
Cosine pi. What is pi?
90 degrees.
That's
180.
pi over 2 is 90. 180, right? So if this is 180, it's in either quadrant
2.
2 or 3. Again, we'll say quadrant 2 most of the time. But again, I want to show how it works no matter which quadrant you go with. What's the reference angle regardless?
0.
0, right? And so what's the cosine of 0?
No.
It is
Adjacent over hypotenuse, 1 over 1. Now if you say quadrant 2, cosines
negative.
negative. If you say quadrant 3, cosines
Negative.
negative. Either way, it's negative 1. So you don't have to worry about it. And that's why you can get away with just saying quadrant 2, because it works the same regardless of which quadrant you try
Did
to
you
put it
make
in.
one that's positive and negative at the same time?
No, that never happens. That's the amazing thing. No matter which function you pick,
So it's theory. It's not even possible.
right, anytime it would be between, for instance, let me drag the camera over here so I can use this. All right, anytime it would fall here, for instance, it's only ever going to have an actual value at sine or cosecant. Everything else will either be zeros or undefineds. And zeros and undefineds don't matter which quadrant. Sine's negative no matter which one. Here, the only one that'll ever happen would be cosine or secant, which will always be, negative no matter which. All the other functions will either be 0 or undefined. So it really doesn't matter which quadrant you pick, which is...
They made it like that?
That math happened to work out that way because we serve a God who doesn't have ambiguity, right? You can't have that ambiguity or there's no answer. But God doesn't work that way. So as we discover mathematics, we're like, wow, it always works perfectly.
There's no way there's not a God. Like, if things like this happen,
Exactly,
it's not possible.
exactly. It's totally illogical to believe there's no God because the perfect patterns that never have exceptions, there can't be. It could not have happened by chance. Whether or not you believe it's Jehovah God or the Bible is, up to you, do your own soul searching, but you have to admit there's a God. All right, cosecant 3 pi over 2. By the way, I believe if you do any soul searching, you will discover it's the God of the Bible. For the record, you too. All right, cosecant of 3 pi over 2. We do preach the God of the Bible here at Grace Christian School. But the point was made for the agnostic. All right, cosecant 3 pi over 2. 3 pi over 2. What quadrant? 3 or 4, we'll say 3, doesn't matter whether you say 3 or 4. Anytime you see denominator 2, you know the reference angle is going to be
60. No, 90.
90. Cosecant of 90.
Cosecant of 90.
Hypotenuse over opposite, 1 over 1. But it doesn't matter whether you say it's quadrant 3 or quadrant 4, cosecant's going to be negative in them both, negative 1. How about this one? Cotangent, 2 pi over 3. Quadrant,
This is going to be quadrant 2.
quadrant 2. Anytime you see denominator 3, reference angle, 60. Cotangent of 60. Adjacent over opposite.
1 over 2.
Adjacent over opposite. 1 over square root of 3, square root of 3 over 3. All right, and quadrant 2 cotangent is?
Negative.
Negative quadrant 2. Negative square root of 3 over 3. How about the secant of 11 pi over 6? Quadrant?
4.
4. Reference angle, anytime you see a denominator 6,
30.
30 degrees. Secant of 30, hypotenuse over adjacent.
2 over square root
2 over square root of 3, or
2 times square root of 3.
2 square root of 3 over 3. Quadrant 4 secant is
Positive.
positive. Positive 2 square root of 3 over 3. Questions on this? Do you feel like you're able to do it tonight?
Yep.
Look at the back of your handout. You've got a bunch of these to practice with. Now here's the key. I want you to finish the chart first by just copying down rows with their positives and negatives, okay? Let that chart be easy. Don't go figuring every one of them individually. Ain't nobody got time for that. Then do the back side of the handout, but don't flip it over and look off the chart. Take the time to think quadrant, reference angle, think through the triangle, and then ASTC. We'll take a look at that handout tomorrow. We do have a test coming up Friday over chapters 3 and 4. That'll be in lesson 32 for my YouTube audience. Have a wonderful rest of your day. You are dismissed.
Just use that.